Is there controversy about the Big Bang Theory?
Well, there's a consensus about what happened after the first microsecond. And it's great progress that after the first microsecond we have a fairly good idea of what happened and how it cooled down.
And what was the Big Bang Theory?
Well, the Big Bang Theory essentially is that everything started off very, very hot and dense and then expanded and cooled, and at some stage atoms formed, and then stars and galaxies formed, etc. And then after about 13 or 14 billion years, we have the universe we see around us, of which we are a part, where on at least one planet around at least one star, a complex biosphere has evolved. So we've got this amazing emergent process starting from this hot, dense beginning and leading up to the universe we are part of. But the very beginning is still shrouded in mystery. As we extrapolate back closer and closer to time equals zero, as it were, then everything gets hotter and hotter, denser and denser. And when we get back into the first tiny fraction of a second, the first microsecond, the problem is that the conditions become more extreme than anything we can simulate here on Earth in our labs. And so things become more uncertain. So from a microsecond onwards, I would say that what a cosmologist tells you about the universe should be taken as seriously as what a geophysicist tells you about the universe.
And there'd be a consensus about that?
I think there would be a consensus.
After the first?
Not universal, but a very broad consensus about after the first microsecond was up. But when we go back earlier still, then the basic physics is still very uncertain, and that makes things more conjectural, more speculative, but on the other hand more exciting, because the only way we may understand and test alternative theories for the extreme conditions that prevail then is by very careful and subtle observations of the universe.
If you collected 10 of the wisest people you know in your field, is there one big question that they most would want to answer, and would there be a consensus on that question?
I think there would be consensus that mysteries lie in the very early stages of our universe, and we won't be able to answer those until we have this unified theory, unifying quantum theory and gravity. They would agree on that. I don't think there'd be quite a consensus, but I'll tell you what would be my main question, which I think many string theorists would agree, and that is the question of how large is physical reality. What I mean by this is there's this huge volume we can see with our telescopes extending about 10 billion years, the aftermath of our Big Bang. But is that all there is? There could be a lot more beyond our horizon that our telescopes can't detect because the light hasn't time to get to us. There might even be other space-times separated from us in an extra dimension, or many, many other Big Bangs. And so many people believe that there's a lot more to physical reality than the cosmic patch, as it were, the volume of space and time, which we can observe with our telescopes. And this leads to a separate question. We know that the laws of physics are the same everywhere we can see with our telescopes. If I look at a distant galaxy and look at its light and take a spectrum of that light, the atoms there are the same as the atoms in the lab. But it could be that there are other domains, other Big Bangs, that lead to cosmoses governed by quite different laws of nature, where gravity is much stronger, where there are different numbers of dimensions, etc. So physical reality may be much richer than a part of space and time we can see. And the key question is whether we will ever have a theory of a kind where we can write it on our T-shirt, which will tell us formally for the strength of gravity, the mass of the electron, and things like that.
Yes, what you said was there's a question as to whether we will ever have that.
Will we ever have that, yes. And the reason we may never have it is it could be that there is a theory, but it applies to a deeper level. And what we think of as fundamental are really environmental accidents, local bylaws in our cosmic patch. Let me give you an analogy. Think about snowflakes. Snowflakes all have hexagonal symmetry, and we understand why that's the case. It's a fundamental feature of the water molecule. But every snowflake is different, and it's different because the way it grows depends in detail on the actual humidity and temperature in the rain cloud where it forms. So for a snowflake, there's a basic symmetry that they all have, and then there are environmental features. Now, what we don't yet know is whether what we call the laws of nature are all bedrock features, or whether some of them may be environmental accidents, rather like the details of a snowflake. And the environmental accidents will be properties of our own Big Bang. So we would be in a region 10 billion years across, which cooled down in a particular way and ends up governed by particular laws. But that may still be just a tiny patch compared to the entire cosmos. So the answer to that question, whether the laws of nature are unique, is very important, because it may require us to take our cosmic modesty one stage further. We've gone from a stage where the cosmos was our solar system plus the vault of heaven, to when it was our galaxy, and to when it was our universe of zillions of galaxies. But it could be that our Big Bang is just one of many Big Bangs, and we have a still grander scale to go to. So that's really the next step, and I would say that's the most fundamental question, to ask whether that's crazy speculation or whether that has a scientific basis.